Hello, welcome you all friends. So today's topic of discussion is simple and fractional distillation. It is also important part from chemistry. So we try to see what is simple distillation and what is fractional distillation. The important thing regarding simple and fractional distillation is that it is mainly used for separation of different liquids having different boiling points. So thus it is a separation technique. So we try to study the simple and fractional distillation in detail. So first of all, before going to see, we try to see what is vapor pressure and what is boiling point. Okay. Now vapor pressure, what it is nothing but, so it is the measure of the tendency of a material to change into gaseous or vapor state. So it is a property of material or liquid basically to convert or change into gaseous state or vapor state. So that we call it as vapor pressure. Okay, every liquid want to convert into gaseous state. So that is vapor pressure. And what is boiling point? It is nothing but the minimum temperature at which the liquid get converted into vapor state. So that is nothing but boiling point. At its boiling point, the liquid starts to boil and that convert into vapor. Now in this diagram we try to see, so evaporation, when it will happens, it will happens only when if the vapor pressure of liquid is less than the vapor pressure of atmospheric pressure. The vapor pressure of liquid is less than atmospheric pressure. In that case, the evaporation will take place. So in evaporation, the liquid will not boil. Liquid boil नहीं होगा. But in case of boiling, so when we heat any liquid, the vapor pressure it becomes equal to atmospheric pressure, and the liquid molecule starts to evaporate. So in both this diagram you will find, in first diagram little molecules are evaporated, while in second diagram the more molecules of liquid that are evaporated, and they are moving in random direction due to acquiring more energy by heat that we have supplied. Okay, so that is difference between evaporation and boiling. So we try to see the next, simple distillation. So this is separation technique. As I said, it is mainly used for separation of two or more liquids. So simple distillation, the assembly it is like this. So simple distillation, it consists of an round bottom flask condenser which is used to condense the liquid or be used to collect the liquid, and a heating source is to be used to heat the liquid. Maybe burner or electric heating can be done. So this is general diagram of simple distillation. A thermometer is to be used to check the temperature of liquid. Okay, so in practical work, in round bottom flask, the mixture that is to be separated is to be taken. So here you can see the round bottom flask. So here this is a round bottom flask in which the mixture is to be separated, it is to be taken. So this is a thermometer, this is condenser, water condenser, and below that it is heating source. So the liquid will boil at its boiling point. See, we are having two liquids, A which is having 50 degrees Celsius boiling point, and B which is having 100 degrees Celsius boiling point. The A will boil as A is having 50 degrees Celsius boiling point, it will boil at 50 degrees Celsius and convert into vapor state. And the vapors will pass, the vapors are allowed to pass through condenser where the water it is in circulation. What is the role of water? It condenses the steam. Okay, it acts as a coolant. So from one end cold water goes, from another end hot water it goes out. So it condenses the steam of liquid, and that condensed steam or water, the condensate that is to be collected at another end in another reservoir, such as this is acetone. So this assembly, it is the separation of acetone and water mixture The acetone, it has a boiling point of 56 degrees Celsius, and water, it is 100 degrees Celsius. So thus the acetone will boil out first, then the water, when the temperature raises to 100 degrees Celsius, the water will start boiling. So in that way the two fractions can be separated. Okay, so this is practical assembly, how it looks like, the simple distillation method assembly. Okay, so this is simple distillation assembly. Now we try to see fractional distillation assembly. So before going to see fractional, the important thing regarding simple distillation assembly is that the boiling point difference between two liquids should be at least 50 degrees Celsius temperature difference. So the liquids which has deep temperature difference of 50 degrees Celsius, that can only be separated by simple distillation. There may be another liquids which has temperature difference less than 50 degrees Celsius. So how they can be separated? They can be separated by fractional distillation method. So thus fractional distillation method, it is used for separation of liquids which has temperature difference less than 50 degrees Celsius. So minimum it should be 25 degrees Celsius temperature difference should be there. Okay, this is also a separation technique. In this case, what is the basic difference is that the fractionating column is used. So this is simple diagram. In this case you can find, so this is fractionating column, this is round bottom flask, and this is condenser. So what is change here? Fractionating column is used. A fractionating column, it separates the two miscible liquids which has a less boiling point. So in that way the separation takes place. The least boiling point liquid, it goes up, higher boiling point condensed in fractionating column again falls down, again it is reheated and reconverted into vapor state. So in that way the process continuously goes on, and in that way we can collect the different samples at different temperature intervals. So there is thermometer which is used for measurement of temperature at which the solvent is taking out. Every liquid had its own fixed boiling point. So by taking that base, the liquid can be separated. So this is general fractional distillation assembly diagram. Here you can see the condenser, heating assembly, water condenser, and the collecting tube. The important use of fractional distillation is in industry in oil refinery. We know that the crude oil, it is the mixture of so many things. It consists of petroleum ether, it consists of naphtha, it consists of heavy lubricating oil, it consists of light lubricating oil, it consists of petrol, it consists of diesel, kerosene, etc. It also contains uncondensed gases. So as to separate all these, we need to use fractionating column or fractional distillation method. In refineries, this is main technique is mainly used. So that is oil refinery. So this is fractionating column. It consists of number of chambers. So here you can see. So these are different chambers. Okay. So it consists of number of chambers, which is fitted with loose cap or bubble cap. So this is loose cap or bubble cap, just like a pressure cooker vessel. So when the pressure build up, the loose cap goes up. It allows the vapors to pass into the upper chamber and so on. So in that way the vapors goes into higher chamber. It also consists of a downspout pipe. So here this is downspout pipe. If heavy refraction goes into higher chamber, that is again taken down into lower chamber through downspout pipe, and it consists of an outlet chamber, outlet pipe. So this is outlet pipe through which different fractions comes. For the separation of crude oil, the crude oil is allowed to pass through first preheater, which is maintained at 400 degrees Celsius temperature. Now why it is heated through at 400 degrees Celsius? To convert into vapor state. The vapor that are fed to the lower chamber of this fractionating column. If it condensed, it will comes out as an fraction. If it is not condensed, it goes up into higher chamber, and if it's condensed there, it can taken out as another fraction. If it doesn't condense, again it goes into higher chamber through loose cap. So likewise, so it goes likewise in higher chamber, in higher chamber, in higher chamber, and wherever it get condensed, it get taken out as a different fractions such as petrol, diesel, kerosene at different temperature level. When we move from bottom to top, the temperature decreases, and vice versa. The heavier fraction get condensed at lower end. As they are heavy, it will settle down easily, while the lighter fraction will be collected at the top side. If any of the fraction doesn't condensed in this fractionating column, it comes out from the top side of the column as an uncondensed gas. Okay, so here the top side, it comes out as an uncondensed gas. So in that way, the separation of liquid is done by fractional distillation. So this is the industrial application of fractional distillation. So thanks for watching this. Thank you.